Alright, this is 10-4. This is the last section of chapter 10, and this is actually one that is very similar to what we've been doing. All we're going to be doing this time is taking the trig functions that we've learned, sine, cosine, and tangent, and applying them into application or word problems. So for 10-4, we have what's called angle of elevation and depression. The angle of elevation is always going to be the angle of when your line of sight and where you're looking is basically you're going up. So if you're standing on the ground and you're looking straight and then you see a bird in the sky and you look up at the sky, the angle that is created from your original vision, which was your direct vision, into the new line of sight, which is to the bird, is an angle of elevation. Whereas if, say, you're in a plane and your normal line of sight is looking straight across the sky, and you look down at somebody or something on the ground, that angle is the angle of depression. So think of it as your original line of sight and your new line of sight when you're looking at something new. A common angle of depression question is a plane, but also when you're, say, in a boat. Or you're on the top of a building. A common angle of expression question is looking at the top of a building or looking at the top of a tree, or you're standing and you're looking at something in the sky. So those basically are your common types of angle of depression and angle of elevation, or angle of depression and angle of elevation. My goodness, questions. Now, when you're doing an angle of elevation, the angle that you typically would use is the actual angle of elevation. But when you're doing angle of depression, a lot of times what happens is you end up having to use the bottom angle instead of the top angle. And I'll do one like that in just a second to show you. So the first question is just kind of getting an understanding of angle of elevation and angle of depression. In this particular one, it says, what is the description of angle 2 as it relates to the situation shown? So I have 4 answer choices here. If you look at angle 2 is this angle created right here. So the dotted line is always, or unless it's specifically noted, the dotted line is your original line of sight. So in this case, your dotted line here is down here, and you're now looking up here. So if you're talking about this guy, he's in the hot air balloon, his original line of sight is straight horizontally, and his new line of sight, he's looking at the bird. So this is going to be an angle of elevation. So if we look at our answer choices, A says, angle 2 is the angle of elevation from the person in the hot air balloon to the bird. That sounds like pretty much what I just said. B, angle 2 is the angle of depression from the person in the hot air balloon to the bird. No, because where he's looking, his line of sight going up to the bird would be the elevation. C, angle 2 is angle of elevation from the person in the hot air balloon to the base of the mountain. Well, that doesn't even make sense. And then D, the angle of depression from the person in the hot air balloon to the base of the mountain. No, it's not an angle of depression. So this is our answer. Next question, suppose a building is located 400 feet from a wind farm turbine. A worker is standing at a window on the second floor of the building. The angle of elevation to the hub of the turbine is 35.5 degrees. That's the hub, just in case you were wondering. The worker's eye level is 15 feet above the ground. Approximately how tall is the turbine from the ground to its hub? This is important, but not until the very, very end of the question, because that section right here is not accounted for when you're finding x. So once you find x, you have to add 15 to it. So in this question, what we would need to do is first determine that our angle of elevation is right here. We are given opposite and adjacent, so we're doing what we've been doing, SOHCAHTOA. This is going to be tangent. So tangent of our angle 35.5 is equal to opposite x over adjacent 400. The next step is to multiply both sides by 400. So we end up getting 400 times tangent of 35.5. So then 400, you would, in the calculator, you do 400 and then push the tangent, and then 35.5, and that comes out to 285, roughly. You would just round to the, you could just, in this case, round to the nearest whole number. But remember that that's just this part, so then we have to add 15 to that, so our total answer for this entire question is 300. Be careful with these because this will happen most, if not all, the time. On our project next week, we'll be doing this, basically, and we'll have to add our height whenever we do that particular height of whatever the object is. So when you're finding the height of a tree, make sure you add your height to your answer, or else you don't have the correct height. Okay, next question. You cite a rock climber on a cliff at a 32-degree angle of elevation, so that's important. Your eye level is 6 feet above the ground, so that's our number that we have to add once we figure out the height that we get when we do our trig function. And you're 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So right now we're going to solve for x, but then once we get x, we have to make sure we add 6 to that. So I see here that I have opposite and adjacent again, which means that I am going to use tangent. So tangent of 32 equals x over 100. So we multiply both sides by 100. So 100 times tangent of 32. That right there is going to be about 625 feet, which you see is answer choice A, but that's not our answer, because we then have to add 6 to that. That becomes 631 feet, so our answer is B. Okay, so on this question it says to approach the runway 17 of the, I'm guessing that's pronounced Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane at the start of his approach? This is an angle of depression question because of the words descent, and in the question or in the actual picture it says angle of descent. So what that's going to mean is when we draw our triangle, these two angles will always be congruent because the line of sight and the ground are always parallel. These are same or alternate interior angles, which means they're congruent. So our angle that we're going to use is the angle of elevation from the airport to the plane. So we're going to use this angle, which is 3 degrees. We're going to draw this line right here, and we have to figure out what that length is. From sea level to the plane is 2,714, but the airport is 1,007 feet above, so we need to subtract those. And once we subtract those, we'll get this height. And so that subtracted is 1,707 feet. Our next thing is to figure out which part of the triangle we're trying to find. It says how far is from the runway is the airplane to the start of this approach. That's our hypotenuse. So this diagonal line is what we're trying to find. So what that means is that based on the angle, we're going to use sine. So sine of 3 is equal to 1,707 over x. So we do our algebra here, times x on both sides. So x sine of 3 equals 1,707. Divide both sides by sine of 3. So x equals 1,707 divided by sine of 3, which gives you about 32,616 feet. But it's said to the nearest tenth of the mile, so we're going to divide that by 5,280 because there's 5,280 feet per mile. And that comes about to about roughly 6.2. So they're about 6.2 miles away from the runway. Okay, last one. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance, d, from the raft? So forgive me for my wonderful artistic drawing skills here. So what I did is I drew the plane, which is supposed to be that thing. The angle of depression right here. The airplane's altitude. Altitude means a line that goes from the vertex and is perpendicular to the opposite side. And remember that in a right triangle, the altitude is always one of the legs. So this length is 3. And it wants to know the airplane's horizontal distance from the raft. So in this case, we're going to put angle 26 here. This is going to be a tangent function. So tangent of 26 equals 3 over x. So when we do our algebra, x is equal to 3 over tangent 26, which becomes about 6.2 kilometers. And if you notice on these questions, unlike the angle of elevation, we don't have to add something at the end. Angle of elevation is usually when you have to add an extra value to the end of it. Angle of depression is when you have to switch using the angle inside the actual triangle that's created. So our project is really big on this. You need to know how to figure out, which sine, cosine, or tangent you're going to use. And you need to be able to figure out how to set up that function and then how to solve for the missing part. So we'll work on this in class tomorrow. You guys have a good evening, and I will see you soon.